In this video, let's finish off the question. Recall from the previous video, we calculated the utility of the worker when the coffee is free. With the same method, we'll calculate the utility of the worker when it's not free. So what do we need for that? We need the utility function when the coffee is not free, and we need the optimal consumption. We calculated that, I think, 2 videos ago. So let's go take all that data and start working with it. It was somewhere in part B over here. We have the utility function. This is the utility function when we expand it. So let's just crop it. The utility function when the coffee is not free, and the consumption of that is going to be n minus 1 over 2p. We can remember that. So we'll substitute it over here. We need space because it's going to be a lot of math. Actually, not that much, but anyway. So this is the utility function, and we said that the optimal coffee consumption in this case would be equal to n minus 1 over 2 times p. So we'll substitute the coffee consumption into the utility function to have everything depending on that coffee consumption, because that's what we're interested in. We want to know what is the change in utility when the coffee is free versus not free. So everything must be compared in terms of the coffee. We'll substitute this into the utility function over here. We have it in this term, and we also have it over here. So what is the utility function now? The utility function when the coffee is not free. That's what we are doing. Let's start opening the brackets over here. That utility is going to be equal to, we have w minus p times c. Let's put it in one bracket. We have w minus p times the coffee consumption. Let's write the coffee consumption in white. We will have n minus 1 over 2 times p. Close that bracket. We move on. Let's write minus n squared. So minus n squared plus 2 times n times c. We have 2 times n times the coffee consumption. Again, let's keep it in the same color, which is n minus 1 over 2 times p minus c squared. So that's still minus this function to the power of 2. Not function, but expression. Expression to the power of 2. That's going to be n minus 1 over 2p to the power of 2. Okay, let's keep solving. This utility is going to equal to, so the utility is going to equal to the following. We will have w minus, we will have in this bracket w minus p times n, so we can multiply those, p times n, minus p times minus a half p. That becomes positive 1 over 2 p to the power of 2. Close that bracket and move on. We have minus n squared from here, minus n squared, plus, let's work with this multiplication. What do we have on this side? We have 2n times n, that becomes plus 2n squared, 2n minus a half times p. 2 with a half cancels out, and we're left with n times minus p. That becomes minus np. And let's open the brackets over there to see what we have. We have minus n minus a half p to the power of 2. That becomes n to the power of 2. Minus 2 times n times a half p, right? 2 times the 2 times each term, that's just the mathematical property of this thing, plus 1 over 2p to the power of 2, plus 1 over 2p, all of it to the power of 2. Close that bracket. Let's keep solving. We can open the brackets over here so that we have the utility function equal to, w minus pn plus 1 over 2 p squared minus n squared plus 2n squared. That becomes plus n squared. Let me color that. Plus n squared minus np, right? We keep writing minus np, and now we can open the brackets over here. 2 and 2 cancels out, so we will have minus n squared. Let me change colors for that. Minus n squared, and then minus np becomes plus np, and then minus 1 over 2p to the power of 2, that's just minus 1 over 2 squared, it's 1 over 4 times p to the power of 2. Let's cancel out some stuff. We can cancel out some terms over here. We have minus np plus np. This one goes away. N squared minus n squared goes away. 1 over 2p to the power of 2 minus 1 over 4p to the power of 2. We're subtracting the same term with different coefficients. 1 over 2 minus 1 over 4 is equal to just 1 over 4. So the utility function is going to be equal to w minus p times n. A half minus a 4 we just said is plus 1 over 4 p squared. This is the utility when the coffee is not free. This is the utility when the coffee is not free. The utility when the coffee is free, we calculated in the previous video. That was equal to w, if I remember. That was equal to, where was it? Here. That was equal to w. So let's take the difference. That's what we said. The difference in utility between free coffee versus not free coffee, and we'll see how much the free coffee is worth to the guys, to the employees. So we will take the difference between w and what we just calculated over here. Where am I? Sorry about that. Yes. So the utility of free coffee is W, meaning we will take the difference between utility of free coffee minus utility of not free coffee. That's equal to W minus this expression. W minus, and let's keep this expression in a bracket because we need the entire expression. We have W minus Pn plus 1 over 4 P squared. Now if we open the brackets, let's see what we get as a result. We will have W minus W minus Pn is plus Pn minus 1 over 4 minus 1 over 4 P squared. W minus W goes away, so these things cancel out, and we have as a result Pn minus 1 over 4 P squared. This is the value of the free coffee to the employees. Hope this all makes sense. In the next video we go to part E.